Hi everyone, it's Miss Lloyd, and we are looking at polynomial and synthetic division. So we're going to do some long division of polynomials and some synthetic division of polynomials. I'm so excited to bring this to you because synthetic division is one of my favorites. I also have a little bit of a song. It's really bad, but you're going to deal with it, and hopefully you maybe like it even eventually, or at least be scarred for life by it and never be able to forget it. Either one is fine with me. So when we're doing long division, it's going to be the same steps for polynomial long division that it is for general long division. So I have my basic division here. Whenever we're looking into it, I can't turn 4 into 3. I can't multiply 4 by something in order to get 3, no solid number at least. So I'm going to move on to 37. So the closest I can get to 37 with 4 without going over is 36. And so in order to get to 36 from 4, I would multiply by 9. So 9 times the 4 would give us 36. From here, I'm going to subtract. So 37 minus the 36 will give me 1. Then I drop down my next number, so 2. I can turn 4 into 12 exactly by multiplying by 3. So multiplying 4 by 3, I would get 12. Subtracting that, I would end up with 0. I'm already running out of room, imagine that. I'm bringing down the next number, which is 1. I don't necessarily need that 0 there. And I can turn 4 into 1, but it's smaller, so I need something larger. So that means I also need to bring down this 4 here. So I'm trying to turn 4 into 14. The closest I can get to that without going over is going to be 12. And so I actually want these to be black. In order to get 12, I would multiply by 3. Remember, I didn't use anything for the 1. There's nothing I could multiply in order to get 1 or something smaller than. And so, but I can multiply by 3 here in order to get the 12. So something that's close to the 14, but not quite over. When I subtract, I end up with a 2. There's nothing else that I can bring down. So that's when we start to get into decimals, or our remainder is going to be this number over our original divisor. So my final solution, I always look at the top for my solution, is 9,303 and 2/4, which is just a half. So when we're looking at polynomial division, so up at the top we had done 37,214 divided by 4. So because we're dividing by our x plus 3, or sorry, x minus 3, that's what's going to go on the outside of my kind of division bar that I have. Underneath, I'm going to set up with what I'm dividing, minus 2x squared, and I'm missing an x. Not all of my terms are represented, so in order to represent that missing term, I'm going to have a 0x. I want everything represented, so that it all lines up nicely. So the first thing I'm going to try to do is to get my x to turn into x cubed. So in order to turn x into x cubed, I would multiply by an x squared. So when I multiply by x squared, I end up with x cubed minus 3x squared. And just like what we did above, I'm going to subtract this from what I'm dividing. So it changes both of those signs when I subtract. My x cubes cancel out, and negative 2x squared plus the 3x squared is going to give me just a solid x squared. I'm going to bring down the next term. This does have 2 terms, my divisor, so I want to make sure that I always have 2 terms that I'm doing the subtraction with. Now I'm looking at turning my x into x squared. So I'm going to multiply by x, a positive x. When I do that, I end up with x squared minus 3x. And again, I'm going to subtract. So I'm going to change both of those signs. I would end up with just a 3x. And last, I want to turn x into 3x. So I would multiply by a positive 3. When I do the subtraction, everything ends up canceling out, so I don't have a remainder. And then when I look for my solution, I'm looking at the top here. So my solution when I divide is going to be x squared plus x minus 3. Sorry, plus 3. And then I'm finished. This next one I'm going to do with my students. It's a little bit more of a doozy, and I'm going to make sure we do it together. My favorite is synthetic division. So I have a lot of steps here. So I can always zoom out a little bit, and you can pause and write those down. I find them extremely helpful. My favorite is the third step in green, and we're going to go through all of these together. So my very first step is to set my divisor. So this thing here, what I'm dividing by, equal to 0. And then I'm going to solve for that variable. So my x is going to be equal to -4. This is technically one of my solutions. I'm going to put that solution in a box in the left corner. No one puts baby in a corner. Well, we're not putting baby in a corner. We're putting a solution in the corner, so it's all okay. Next, I'm going to write each of my coefficients next to the box. So the 2, the 9, 1, and -12. And we do want to make sure that each term is represented. So I went from cubed, squared, linear to constant. Everything is there. I'm not missing anything that should have exponents. And we're only writing down the coefficients. We don't want the variables. Now that I have all of those written down, the very first coefficient, I'm going to drop it like it's hot, drop it like it's hot, drop it like it's hot. It's okay. You will eventually have to say it to me, my students, and it's going to be awesome because they're scarred for life. For life. All right, so we drop our 2 like it's hot. Once we've dropped that, we now have a number that we can multiply our box number with. So all of the numbers below the line, we multiply with the box number in order to get the next one. That number will subtract with the second coefficient. So -4 times that 2 would give me -8. 9 minus the 8 will give me 1. I multiply again my -4 with that 1, and that will give me my next number. So -4, and I'm going to add that with the third coefficient. So 1 plus my -4 will give me -3, and I keep going. I just keep repeating this. So -3 times a -4 will give me +12, and -12 and the +12 will give me 0. I don't have any more numbers, and so this very last number below the line is always going to be my remainder. So here I technically don't have a remainder. So my solution, these numbers below the line, are now the coefficients for my solution. Because we started with an x cubed and we divided out an x, that means that I now have a 2x squared. So x cubed divided by x gives us that x squared plus 1x minus 3. So using all of these numbers here as my new coefficients. It seems like it's really complicated, but honestly it's not, and it's so much quicker and a lot less time consuming and a lot less hair pulley outy than the long division. Again, I'm going to do the second one with my kiddos. I like them more than people I don't know. Everyone else is just going to have to get over it. We also have this thing called the remainder theorem. So if I have a number, and we divide by the factor, so x minus 7 or x minus 5. That would be the same as if I plugged in -7 or +5 into the function itself. That remainder is going to be its solution. So what I mean by that is here I'm saving that 1/2 for my students. So if I were to plug -1 into every single one of these x's, this is going to be exactly the same as if I plugged -1 into the box and did some synthetic division with this. So I have 4, 10, -3, -8. I'm not missing any terms, so I'm going to drop it like it's hot, drop it like it's hot, drop it like it's hot. I'm okay. Multiplying with -1, we'd get -4. Adding that together, we would get 6. 6 times that -1 in the box would give me -6. This would give me -9. And then -9 times -1 would give me +9. And then -8 plus 9 is going to give me +1. So this +1 here, if I were to have plugged in -1, it's the exact same one that I would have gotten here. So instead of plugging everything in and narrowing it down, so if you have a calculator, instead of doing the remainder theorem, it's a lot easier just to plug it in. But say you're in a non-calculator portion of something and you really like synthetic division and you've done it a lot and it makes you happy, um, eventually you're going to get it to where it's going to be a lot quicker to plug something into synthetic division than it would be if you just wrote it out this way. It takes me a lot longer to do it plugging in way than it does the synthetic division way. So these are always going to be the same solution. Whatever that remainder is going to be the solution for if I were to just plug it in itself. Fun fact, factor theorem. So we can divide something out evenly or something is a factor if whenever we dwindle everything down or we do our synthetic division, our remainder is 0. So whenever we do division or long division, we knew that something was a factor if we ended up with a 0 as our remainder or no number at the end. So we're doing the same thing here. If I want to show that x minus 2 is a factor, I'm going to first set this equal to 0, so x would be equal to 2. I'm going to plug that 2 into the box and do synthetic division and hope that my remainder is 0. It does say to show that it is a factor, so my remainder should be 0 when I do this. Drop it like it's hot, drop it like it's hot, drop it like it's hot. I'm okay. And we do indeed get a remainder of 0, so because my remainder is 0, x minus 2 is a factor. And then the last bit I am going to say for my kiddos. So I hope you guys have found this helpful. If you did, please like and subscribe. If you know of someone who this would be helpful for, please feel free to share. Spread that love.